So in the last classes, we have started with the Spring Data JPA module. It's very important module. It's mainly to remove the boilerplate code from our application. And how to go with Spring Data JPA? By using two repository interfaces. One is code repositories and one more JPA repository. And we are seeing about code repository. Like in our case, we have taken the class codes with the entity class codes with properties like course ID, course name, course duration, and course fee. And we have done the database connections using application.properties file. And we have created this course repository. How to create? See, very simple. Just we have to create interface, course repository extends, code repository. And here we have to provide the entity class name and primary key data type. That's it. And we have taken the Spring Boot application a test class where we are getting the pin course repository class, and we have seen how to do the insert operation. For insert, we use save method. For count, we use count method to count the number of records. And find by ID method we have seen. Then we have seen find all method to return all the records. And we have seen update operation using save method. And we have seen the delete method and delete all records. Now, today, let us move to the next part. Like if you connect to our MySQL, use SpringDB, our database. What is the name of the table? Course details. Select star from course details. Run this query. See, we are having no records present in the table. We are not having any records. Now let us add some courses here. So here, let us move to the next method, save all method. So I want to add multiple course objects into the table. So what is our next concept here? Adding multiple persistent objects using save all method. Now let us create some courses. Course C1 equal to new course. Then we'll go with the course ID. We'll go with course ID. Then course name. Then the duration. Then fee. Like that, let us create some course objects. We are creating totally 5 courses here. Just we're adding some courses. Some courses we are adding. So we are in totally 5 course objects here. Now how to add these objects into the table now. So for that one, say here list course little package with a method as list. Go here, list courses equal to arrays dot as list, and to this as list add our courses, the objects here C1, C2, C3, C4 and C5. So we are adding these 5 courses to this courses list. Now there was some problem with the audio. So what we are doing here, we are creating arrays dot as list and we are adding all these 5 course objects to this courses list. Now next thing what we have to do is by using repo, we have to call which method? Save all. To the save all method, just pass our courses here. That's it. So now when we run this code, run as Spring Boot app, it's going to add all these 5 courses into our table. See, it's all doing insert operation. And if you check your database table, see all 5 courses got added into the table. Clear the need of save all method? Right? Now, moving to the next one, using find all by IDs. Using find all by ID. Now, for this one, say here list string course ID is equal to, go over here arrays dot as list, and we are adding 2 courses here like full stack Java and UI. Full stack Java and UI. So these two primary keys. So what is the use of find by ID? It is going to return only one record. Now find all by ID means I want to get the records based on multiple primary keys. So that is the place where we go for find all by ID. So for that we are creating this list of course IDs using arrays dot as list. We are adding these 2 primary keys to these course IDs. Now the next step, go here with iterable course is equal to repo dot find all by ID. We have to say what? Find all by ID and pass for course IDs. Now print these courses. System.out.println, not system.out.println, this one. Courses dot for each. Then you can say system.out to colon println, the method reference. Now see, when we run, we get only 2 courses on our console. It is displaying, see, 2 courses here like course ID full stack Java and course ID UI. So whichever the primary keys we have passed here, only those 2 records it is displaying back to us. That is the use of find all by ID. Clear up to here? Any questions? Moving to the next concept here, find by methods. Let us move to the next one. Find by methods concept. Find by methods in Spring Data JPA. So what is this find by methods is? Here, what are the predefined methods provided by Spring Data JPA? It is based on your primary key. It's mainly based on your primary key or to get all the records. Now I want to get the records on non-primary key columns. So in this example, we are having, I want to get the records based on course name. I want to get the records based on course fee. I want to get the records based on course duration. Non-primary key access. So for that case, we go for this find by methods. So what is the use of this one is to retrieve to retrieve the data from a database table based on non-primary key columns. We use find by methods. Go forward, find by methods. Now, when we write find by methods, JPA constructs. JPA is going to construct the queries for us. JPA constructs query based on method name. So based on the method name, it's going to construct the query. Like example, you can say find by course name. In our case, in our example, find by course name. Find by course duration. Find by course fee. Like this. So like this, we are to create the method. So based on this property name, it is going to form the query for us. It's going to form the query. Now, let us understand how to go with this one. So go to this repository. Here we have to create the methods explicitly now. Because JPA won't provide this methods implicitly. We have to create the methods. Then JPA will write the code inside the methods. We need not write the code inside the methods. Our work is only to provide the methods here. Like example, if you take here in this course repository, we'll say here public list codes find by course duration, which takes course duration here as the argument. That's it. Our job is done now. So the internal code is taken care by your Spring Data JPA. Our work is only to create the method. And this is very, very important. So whatever the property name, the method names are very, very important. So whatever the property name we are having now, course duration, that same method should come here. Find by the property name should come here. So based on that, it's going to construct the query for us. Check it here. Coming to our test application. Coming to the test application. Here we'll say. So here we are going to discuss find by XXX methods. XXX means it can be any property name. Now here we'll say list codes is equal to repo dot find by course duration. See, the method is coming here. Find by course duration. We'll say here 3 months. We'll say 3 months. Then say courses dot for each system dot out to colon println. Now see, when we run, we get only the courses whose duration is 3 months. So how many records are there? There is only one record whose duration is 3 months. Check it in your table. There is only one course with the duration 3 months. Now let us go with 4 months here. 4 months we are having 3 records. So let us check whether it takes 4 months, whether it is going to return 3 records. So here run as Spring Boot app. Here it's returning 3 records whose duration is 4 months. Right? So just our work is only to construct the method here. Then Spring Data JPA will take care of writing the query for this method. One more example. Public list codes find by course fee. Find by course fee, where we are going to pass our course fee here as argument. Now, I'm keeping this code in comments. Now, see here, list course is equal to repo dot find by course fee. Find by course fee. Do you have any course fee with multiple? No, right? Same thing is there, only one. So find by code speed, we'll say 18,000. Find by code speed, 18,000. Then get the list of records. Now see, we have to get only one record based on this. Here it's returning only one record, UI, which is having code speed as what here? 18,000. Code speed is 18,000. Right? One more example. Let us create one more method like this. Public list codes. Find by course fee less than equal. See the goodness of here. Find by, just if I say find by course fee, just if I say find by course fee and press on your keyboard control space. So here you can see all the methods here. You can see the methods here. Find by course fee. Here in our case, I want to go with less than equal. See the methods will come to us. So many methods are there here. Find by course fee less than what are the codes fee we provide here. That's it. Now come to this. I'm keeping this code in comments. So we can say less than, greater than, equal, anything. Anything we can say here. So what is this? Find by codes fee less than, equal. Then we'll see something like 19,000. Now see when we run, we have to get the records only the fee which is less than 19,000. Here we are getting only the records whose fee is what? Less than or equal to 19,000. It's not displaying all the records for us. So like that, whichever the methods you want to construct, you can just construct that methods over here. And it should match with our property names. The property names are very, very important, but it should match with our property names. Based on that only we have to form the methods. And Spring Data JPA will write the code inside this methods. We'll construct the query based on our method name. One more example. Public list codes find by codes fee greater than, find by codes fee. You can, once you press control space, you can see the methods. Greater than, equal, we'll take the codes fee. Okay, so here we are having the methods greater than, equal, we'll say 18,000. 18,000 means we have to get 18,000, 19,000, 20,000. 3 records we should get. Now, come to our test application. Here, which method we should call? Repo dot find by course fee greater or less than, greater than. So we'll say 18,000. Now see when we run, we get only the records whose course fee is greater than or equal to 18,000. So here we are getting only those courses over here. So this is the beauty of Spring Data JPA. Clear? Any questions? Let us move to the next concept here. Custom queries. Custom queries means we can write our own queries here. How to go with custom queries is, in Spring Data JPA, we can execute custom queries. Custom queries. At the rate query annotation. At the rate query annotation is used to execute custom queries. In order to execute our custom queries, we have to use which annotation? @query annotation. @query will support @query will support for executing both SQL queries. SQL means Hibernate query language, and native SQL queries. Native SQL means your database related. Based on the database syntax, we have to write that. Right? So when you go with HQL is what? Hibernate query language. And these are database independent. SQL queries are what here? Database independent. And here, this is applied on model. So the meaning of applied on model means we have to provide our entity class name and entity property names. Entity class property names. In our queries, we have to use what here? Only entity class name and entity property names. That is the meaning of applied on model. And this is poor performance. HQL is what? Poor performance. Because of conversion. So internally, we have to convert our HQL to SQL. So because of that, it is poor performance. Coming to SQL, structured query language. Structured query language. This is database dependent. Structured query language is for database dependent. So whatever the query we are writing, if we change the database, again we have to go to the query and change the SQL query. That is a point called as database dependent. Here in this case, we use table names and column names. So here in this case, we go with entity class names and entity class property names. Here we go with the table names and column names. And this is better performance because no conversion is required. Conversions are not required. That is the reason native SQL is better performance. Now, let us go with the example over here. So come to this repository. Here we create a query. Just we have to use the notation @query, and you can say value equal to select star from course details. So this is our table name. So what is the table name we are having? Course details. That same table name, this column names only we have to use here. So we are writing select star from course details and say native query as to. So we are indicating that whatever the query we are writing, it's a native query. Then now create the method public list course get all courses. So when I use this method in our application, the internal meaning of this method is what? This select start from course details. So I'm creating my own method name. So in the previous case, we are using predefined methods. Now I can even go with our own method names, and for that method, we can map to this query. So whenever we call this method, internally this query will get executed. Select start from course details. Now, let me show the result. Come to our application. Come to our test application. Here we'll say list courses equal to repo dot get all courses. So we have created our own method now. We have created what here? Our own method. So what is our method name here? In course repository, what you have created? Get all courses. Get all courses. So whenever we call this method get all courses, this query will get executed. This query will get executed. So which is going to return all the records from the table. Now we are calling this method repo.get all courses. Then print the list of courses. What is the concept we are learning? Custom queries. Custom queries means we are going to create our own queries in our application. Run this. Here we are getting all the records from our table. This is what your native query. We call this one as native query. Now, if you want to go with HQL, so just to say at the rate query, just simply we say from courses. From courses. So just simply what we have to use from course. That's it. So what is this from course? Course is what here? Our entity class name. So when you go with HQL, HQL is based on our entity class name and entity property names. So here simply we say from course. That's it. So this internal meaning is select star from course details. Then let us create the method public list course get courses. So whenever we call the method get courses, so here it is a HQL query. If you are not mentioning anything like native query as true, then automatically it's going to take HQL query. So when you say get courses, this command will get executed, which is going to return all the courses to us. Check it here. This example is related to custom queries. Which method we are calling? Repo.get courses. Just I'm calling which method? Get courses. Then what are the courses we are having? That courses will come and store here that we are displaying here. Now, when we run, it's going to return all the records present in our table. It's returning all the records. Next one. Let's go with the conditions here. Let's go with the condition. Let us create a method. Just a second. Let us create a method here. At the rate query value equal to select star from course details. Select star from course details where course fee less than or equal to given, and it is a native query. Native query equal to true. Now write the method. Create the method list course get course fee. We are creating our own method now. Get course fee less than equal of given fee. So what will happen now? Whatever the key we are giving as an argument, whatever the fee we are giving it as an argument, that will get replaced over here. That value will get replaced here. Okay. Now come to our test class. Now call the method here. Call the method repo.get course fee less than equal to. That's the method we have created now. get codes fee less than equal to. So we'll say 19,000. So we are going to get the records whose fee is what? Less than 19,000, less than or equal to 19,000. See here. Run as Spring Boot app. Here we are going to get only the courses whose fee is what? See, less than or equal to 19,000. So we are having one more course whose fee is what? 20,000. That is not coming. So if I change the value here to 18,000, now see what records where it is going to display. It is going to display only the records whose course fee is less than or equal to 18,000 here. 19,000, 20,000 are not coming. So in that way, we can create our own queries. So just create the method, and for this method, this query will be applicable. So this is what here native SQL. Then how to go with HQL? So just we have to write like this: @query, @query. Just we'll say from codes. From codes, we have to use the entity class name. From codes, where codes fee, we have to use the property name greater than equal to colon fee. Greater than or equal to colon fee. Now create the method list codes. List codes. We are creating the method get codes fee. Get codes fee greater than equal. What happened? Greater than equal, and what are the fee you are passing as argument. So this fee, whatever you are passing argument, that will come and store into this colon fee. So here we are going to get the courses whose course fee is greater than or equal to the given fee. Now, come to this. Let me copy this. I'm giving this code in comments. Paste here. Call the method. What is the method name? Dot get. What happened? Dot get whose course fee is greater than or equal to given fee. So let me take it as 18,000. So here we are going to get only the records whose fee is greater than or equal to 18,000. So here, when you run as Spring Boot app, we are going to get only the records whose fee is greater than or equal to 18,000. Right? So this is the way to go with what? Our own queries. So these are what here find by XXX methods. And these are our custom queries. So these methods are related to find by XXX methods. We call this find by XXX methods, and these are our custom queries. So we can create our own queries here. So these concepts are very, very important to us. Right? Anyone having any questions before I go to the next topic? Let us move to the next one, that is JPA repository. JPA repository interface. This is similar to code repository only, but it's having some additional functionalities. JPA repository is a predefined interface in Spring Data JPA. JPA repository provides methods to perform CRUD operations. So here also by using this we can perform CRUD operations. So whatever we have done with code repository, same thing we can do with JPA repository. So what is this JPA repository? JPA repository is equivalent to code repository. Yes, it goes with paging and sorting. It goes with what? Paging and sorting. Okay, some additional features it's having. Now, let us understand what is this paging. So this concept we call it as pagination. So what is the meaning of pagination is like, if you take example like Google search, if you are searching for something like Spring tutorials, Spring tutorial. So here, if you scroll down, you can see the pages over here. See page 1, page 2, page 3, page 4. This concept only we call pagination. And what is the size of this Google search? 10 pages. So by default, it's going to display here. It's displaying the results here. Okay. Then, even if you go with Flipkart, and if you are searching for products here, something like watches, here it is doing. It's if you scroll down, you can see that paging numbers here. There is that. Wherever you see some page numbers, no, that we call it as pagination. So even if you take Gmail also, it's not going to show. See here, it's showing one of 40 products. Showing one of 40 products. Here you can see one more page 2. You can see here page 2. This concept only we call pagination. See, it's showing the remaining products here, 41 to 77. Even if you take Gmail, will it show all the mails to us? No. So by default, it's going to show 50 mails. So page, next page like that. That concept only we call pagination. Now, what is this pagination is? Displaying records of table in multiple pages. Displaying the records of your table in multiple pages is called as pagination. So examples are like Google search, Gmail. You can see Flipkart. Okay, so many places we can see the concept of pagination. Then, let us understand this with the example application. Let's go with an example application. Create an entity class. Create an entity class employee. Let me take the package name. This is our package for our entity class. So once we create entity class, the next step is creating repository interface. Let me go with the name employee repository in this package. This is our package for repositories. Employee repository. Creating Spring Boot application.java in this package. So wherever we have created the test application, so in this package, let us create application.java. This is our test application. So the test application name can be anything. So in the previous case, we have directly used this Spring Boot Spring Data JPA application. We can even change the name of this class here, and with the main method and same code will remain same. Now, let us do the steps here. This application we are trying a Spring Boot app. Let us develop this application. First of all, let us create one entity class. So we're going to create an entities package. Let us create the entity class employee. Then go with the properties. Provide int employee ID. Provide string employee name. Provide string designation. Provide integer employee salary. These are our properties. Then apply the Lombok annotation @ no aux constructor @ all aux constructor @data for setters and getter methods. Now go with the JPA annotations @entity @table. Let us go with the name of the table as employee details. Then mark this employee ID as primary key @ID @column name equal to emp_id. Let us change the column names for other properties @column name equal to emp_name @column name equal to designation @column name equal to emp_salary. Import the respective packages. That's it. Your entity class is ready. Now, our next step is create the repository interface. Go to this package repositories, right click on repositories package and create a new interface. Let us go with the name employee repository. We are going with the name employee repository. Make this repository extends. We are going this time JPA repository. And what is our entity class name? Employee primary key data type is integer. That's it. Your code is completed. Then above this, you can go with the optional annotation repository. Then, now let us go with the test class. So for that one, right click on this com.rajtech.springboot.jpa, create a new class, and I'm going with the name application with main method inside. Now, just to copy the code from this. So same code here, that is the application. So here we are going to get this. What you are doing? Configurable application context equal to spring application.run, and here what is our name of the class? Application.class comma args. Now what is our repository name? Employee repository. Repo equal to context.getPin, same employee repository.class, which is going to create object of our employee repository. Done. So now our repository is ready. The repository object is ready. Now let us create some employee objects and add it to the table. So let me create some employee objects. Employee E1 equal to new employee. And we are going with the employee ID, employee name, designation, and salary. So we have created one employee object. Like that, create some more objects here. I'm creating totally 8 employee objects here. We are creating 8 employee objects. Let us change the data. 101, 102, 103, 4, 5, 6, 7, and 8. Change the names. Some values I'm giving, okay. We are just adding the objects here, just creating objects so that we can understand properly. Last one. So we are in totally 8 employee objects. Now I want to add all these objects to the database table. So how to add here? Just to say here list employee, employee is equal to, but we have to use arrays dot as list. To this, just add all our objects like E1, comma, E2, comma, E3, comma, E4, comma, E5, comma, E6, E7, and E8. So we are creating arrays.list as list, and we are adding all these employee objects to this employees now. Now just to use the method report dot, which method we have to use to add multiple objects? Save all. We have to use which method? Save all, and pass for employees object here. The list of employees object. Now run this code up here. Run as Spring Boot app. Employee repository. Okay, here we have to annotate it as Spring Boot application. So once we annotate it as Spring Boot application, then only this will become the entry point for us. Run as Spring Boot app. See here it's working. See it's what it's doing. See, it's creating the table for us. It's creating the table employee details, and it is even inserting the records into the table. Check it here. Select star from employee details. Let me check the table name once again. Right, employee details. Now, run this query. See here, we are getting all the records got added into our table. Got it up to here? Now let us understand the pagination. Let us go with the pagination. Now I'm keeping this code in comments. Now we are having totally 8 records. Now I want to display only 3 records in each page. I want to display what? Only 3 records in our each page. Now, so for that one, let me accept the input from user. Scanner is equal to new scanner. To accept the user input, we use scanner class. Now see here. Enter page number. So which page number you want to display? Enter the page number. So here we'll say int page number equal to s.next. So we have accepted the page number. Now we'll take page size. We'll take here what? Page size as 3. What is the meaning of page size? How many records you want to display? How many records you want to display? That is our page size. Page number is which page number you want to display. So here we are going with simple console application, not a graphical, not a web application. That's the reason I'm accepting page number manually from user. And page size we are giving it as 3. Now apply here list employee employees equal to repo.find all and we'll see here employees dot for each system.out to println. What this is going to do? This is going to return all the records present in our table. So this is going to return all the records present in our table. So let me go with some page number like 1. Okay. So this is not required for this example. See here, it is displaying all the records present in our table. So total 8 records it is displaying. Now I want to display 3 records only. So now apply the pagination. I'm giving this code in comments. Now apply the pagination. How to go with pagination is, say here, page request equal to page request dot off page number -1. So if I say page number as 1, I want to display page number 1. So always remember page number starts from 0 onwards. So for user it is 1, but for internally it is going to start with 0. That's the reason we write here page number -1. So remember, page number will start from 0. That's the reason we are writing page number -1 and we are giving the page size. So what is the page size here? 3 means 3 records we want to display. Now see here, page employee pages equal to repo dot find all, and to this we have to pass our page request. Then now see list employee is equal to pages dot get content. Which method we have to call? Pages dot get content. So for this page request, we have applied page number -1, page size. In our case, 3. That's it. So all the records will come and store into employees. Now display this employees here. Now, check it here when we run. It is going to ask you the page number. So I'm giving page number as 1, means first page. See, it is displaying only 3 records here, 101, 102, 103. 3 records only it is displaying. Now let me run the code again. Now it will ask page number. If I say 2, then it's going to display the 104, 105 and 106. Now if I run, so it's a manual entry here, but in reality we won't do like this because we go with web applications. If I say 3, it's going to display 107, 108 because we are having only last 2 records in the 3rd page. So this concept only we call pagination. Okay. Next one, we are having one more simple one, sorting. So just to say here, list employee is equal to repo.find all, and you can use here sort dot by using sort we call by, and I want to sort the records based on employee name. We want to sort the records based on employee name. Then get the list of records. Now see, when we run, we get the records sorted by page. Let me have to keep that code in comments. Let me run this. Here we are going to get the record, see, based on employee name, alphabetical order. So here we are getting based on alphabetical order. By default it is ascending. If I want to go with the descending, order, we'll say here Same method, say here dot descend. That's it. When you say dot descending, we are going to get the records based on employee name, descending order. Sort by employee name, descending order. See here, first it's starting with Smith, Satish, like this. Then one more example. I want to sort based on salary. Sort by employee salary. We want to sort the records based on employee salary. Now see, when we run, we get from ascending order based on salary. Here, starting with what? 50,000, 55,000, 60, then finally 90,000. So this is the way to do this sorting process. So this pagination and sorting concept is available in JPA repository. These things we cannot perform by using code repository. Okay. So please practice this compulsory, and tomorrow let us start off with one more new topic. Thank you all. Thank you very much.